All right, let's jump straight into this explainer. We are unpacking a massive, literally game-changing technological shift today. We're watching human pilots being rapidly removed from the cockpit, which is completely reshaping modern combat and redefining global security as we know it. I mean, the battlefield is transforming right before our eyes, moving away from traditional crewed aircraft to this incredibly complex ecosystem of unmanned systems.
So here's what we're looking at today. We're going to climb the escalation ladder, starting with the FPV tactical revolution, then scaling up to swarms and loitering munitions. After that, we'll hit next-gen jet combat drones, and finally, wrap up with the anti-drone defense race.
Okay, Section 1, the FPV Tactical Revolution and the Dawn of Agile Warfare. Let's start small, really small, right down at the ground level where individual soldiers are using highly maneuverable tech to basically dominate high-altitude and line-of-control scenarios.
Now, you might be wondering what exactly sets a first-person view or FPV drone apart from other advanced military UAVs. Well, it's actually what they lack. They don't have autonomous navigation. There's no GPS stabilization or heavy AI-assisted controls holding their hand. Instead, an FPV gives the operator this near-instinctive bird's-eye view right into contested zones. It relies purely on the raw skill of the pilot holding the controller.
And you can see that bare-bones approach when you look at their anatomy. Skipping the heavy AI and GPS is exactly what keeps them so incredibly lightweight, dirt cheap, and, frankly, lethal. The pilot wears goggles that act as their eyes on the battlefield, catching real-time, low-latency analog video. Combine that with some brushless motors and an electronic speed controller, and these pilots can thread the needle in super difficult environments, like the thinner air you get at high altitudes, with absolute pinpoint precision.
What's really fascinating here is the stark contrast when you put an FPV's dynamic agility up against the rigid flight paths of older anti-tank guided missiles. Those older ATGMs basically follow a predetermined path, maybe a tiny mid-flight correction here or there. But FPV drones, they have 6 degrees of freedom. They can sharply pitch down into a dive, roll out of the way of an obstacle, instantly accelerate, or just hover in place. It gives them a massive tactical edge against entrenched positions in really complex terrain.
But there's a catch, right? While they can absolutely scream at over 100 kilometers per hour in a dive, they rely entirely on the real-time judgment of a human who is likely operating under extreme stress and disorientation. They don't have those fail-safe telemetry features you'd find on high-end UAVs. Plus, their battery life is usually under 10 minutes. So, they're a fast, intense, but highly constrained asset.
All right, let's scale things up. Section 2, loitering swarms, where mass meets precision. We're moving from the tactical level to the strategic level now, looking at mass-produced loitering munitions. We are jumping from drones that last 10 minutes to autonomous platforms designed to carry explosive warheads anywhere from 3 to 50 kilograms. These things are striking pre-designated high-value targets, like radars, buildings, and critical infrastructure, across distances that span thousands of kilometers.
And this didn't just happen overnight. Over the last 50 years, this concept evolved from an abandoned American and German anti-radar idea into a deeply ingrained global military strategy. Nations saw the potential, copied the simple designs, and iterated. What started as a niche tool to hit mobile surface-to-air missiles grew into massive families of munitions today. Think the Babel, the Samad, and, of course, the heavily utilized Shahed platforms.
The operational life cycle for these threats is almost frighteningly streamlined. These relatively simple GPS homing munitions go basically straight from the factory floor to a devastating swarm attack. Operating them doesn't even require high-level technical expertise. They're built cheap, warehoused in logistics hubs, and then pushed out to deployment zones to overwhelm air defenses just through sheer volume.
And they're constantly improving. Thanks to battle-tested engineering and sourcing components globally, like from China, we're seeing the creation of really robust, hard-to-jam weapon ecosystems. Take the production facility in Yalabuga, Russia, for example. They've reached roughly 90% localization for Shahed drones. They're rapidly replacing imported subsystems and iterating, creating a highly capable, low-cost munition that is becoming much, much harder for defenders to shoot down.
Okay, let's push even further into the cutting-edge future. Section 3, Next-Gen Jet Combat Drones and Future Air Dominance. We are officially leaving the propellers behind for platforms that look exactly like stealth fighter jets.
Just look at the specs on Turkey's Kizilelma. Compare these massive numbers to the tiny loitering munitions we were just talking about. This is a jet-powered platform with an 8,500-kilogram max takeoff weight and a 1,500-kilogram payload capacity. It can hit Mach 0.6 and cruise at an altitude of 13,700 meters. And the absolute craziest part? It executes takeoff, cruise, and landing entirely autonomously. It's a monumental leap in strike capability.
And these aren't just concepts sitting on a drawing board. Take the recent incident over Ukraine, where Russia's S-70 Okhotnik B was actually shot down by a Russian fighter. The wreckage confirmed it was carrying at least one precision-guided glide bomb. This tells us these heavy, stealthy drone bombers are highly operational and actively testing their internal weapons base in live, contested conflict zones.
The strategic rationale here makes perfect sense. As air defenses get more lethal, pushing human pilots further and further from the front lines, militaries are going all in on these massive robotic jets. They have low observable characteristics, meaning they can penetrate deep into hostile airspace and deliver heavy ordnance without putting a human pilot in danger. Of course, warfare is a constant action-reaction cycle, so moving to Section 4, the anti-drone defense race. Let's look at how defenders are scrambling to neutralize this escalating threat.
We're seeing a sheer variety of electronic warfare, or EW, tools hitting the field. On one hand, you have ground-based systems like Ukraine's Anklov or the Nota, which jam cellular communications and neutralizing incoming drones. On the other hand, you have systems like the Gektamota, an airborne electronic intelligence system mounted directly onto a UAV, specifically designed to hunt down enemy air defense radars from up to 450 kilometers away.
The global market is throwing everything it has at this, creating multi-layered defense approaches. They're using AI and machine learning to crunch sensor data in real time. Because drones are everywhere now, commercial systems like the Irania ARTOS are protecting international airports, while military giants like Elbit Systems are blending radar and optical tracking to spot threats early. Even systems like the Iron Dome are being enhanced to detect and mitigate these low-altitude, agile targets.
What's truly revolutionary, though, is the birth of remote combat control systems. Take Ukraine's masterclass in adaptation. They successfully integrated anti-aircraft interceptor drones onto unmanned surface vehicles, basically drone boats, and even onto An-28 aircraft. Think about that for a second. An operator sitting comfortably in a remote capital can use a video feed to lock onto an incoming loitering munition and take it out mid-flight using a networked interceptor drone.
As Defense Express noted, Ukraine is currently the only country with a full-fledged anti-drone defense system featuring all the necessary components. But the real takeaway here is that this isn't just a random assortment of weapons. It's an evolving, integrated system of systems. Detection, EW jamming, kinetic interception, remote command, they are all talking to each other seamlessly. And soon, this could expand to unmanned carriers loitering autonomously for hours, just waiting for an AI to predict an incoming enemy swarm attack and activate them.
So, here's the ultimate question I want to leave you with as you digest this explainer. As automation completely replaces the human pilot and defense systems become these fully integrated networks, how will this escalation ladder shape the global conflicts of tomorrow? From tiny FPVs dodging trees to long-range loitering swarms, all the way up to 8-ton stealth jets, the skies have changed forever, and the networks catching them are becoming just as autonomous. Thanks so much for taking this deep dive into the fast-moving world of modern combat with me.